Okay, fair enough. I've got that one queued up here because I knew we wouldn't get done early. Then we have univariate data description, lecture one variable at a time. So those of you who've had any kind of intro stat before, a lot of this is going to sound familiar. So you can sit back and feel relaxed that you know what's going on. And if not, then hey, that's why we're talking about it here. So we're going to have two sections to this. First, just how to summarize information. What are the salient features of a variable that you would want to find and convey to other people to describe its contents? So that's sort of descriptive information. And then changing gears to head into what's known as inferential statistics, which is then taking that information and trying to decide what we can and cannot say about a population from that one sample. So trying to make some sort of extrapolation. You know, we just finished election season last fall, of course. Still controversies going on today. But the best example of the difference between those two that I can think of is all the election polls, right? New polls come out every hour, it seems like. Oh, Biden's up by this, Trump's up by this. And it's fine to say that, it's 53-47 right now. That's a descriptive statistic. It captures the results of this one poll. But then to say, okay, does that mean that we know who's going to be elected? Right? That's inference. That's going from my one sample and trying to go back to the population. So it's two different goals. And usually when we do quantitative data analyses, we're trying to do both. We want to summarize what happened in our sample, but we also want to talk about how that corresponds to some sort of expectation that would be in the population. So we're using univariate statistics as a way to introduce those two types of purposes, ways of gathering information. So univariate, as you may imagine, univariate means one variable. Can you guess what bivariate means? Two. Yeah, see, I accept gestures. And we don't have trivariate, by the way. That's not a thing. After two, it just goes to multivariate, many. So, or quadvariate, also not a thing. So univariate, bivariate, and then multi. So we have our two main types of variables as we went over. If you're dealing with a categorical predictor, then all that's really relevant in terms of summarizing it univariately all by itself is the frequency of responses in each category. So you need to know how many categories there are and how many responses are in each category. Because raw frequencies, you need to know out of how many total to make sense of that. They're often converted into either percents or proportions. So percentages go from 0 to 100, and proportions go from 0 to 1. And I make that point because a lot of the software packages give you percentages, but then to do statistics on the percentages, you have to change them into proportions. You got to move the decimal point over two places. And I'll show you code here in a second to make pictures. Bar graphs, as they call them, or frequency plots, and adding value labels to make sure that the viewer of your plot knows, like, what does 0 mean, what does 1 mean. That makes it easier to convey the information. Come back here. There we go. So for instance, welcome to SAS. I have SAS and Stata. This is what it would look like to ask for the frequency of responses to a variable with 5 options for your marital status. So Sas Syntax, as it's known, you can think of it as code, is the set of instructions that tells the program what to do. Just like SPSS, both SAS and Stata have drop-down windows. You can use drop-down windows to pick amongst things. They're inefficient. It's easier just to have little snippets of code that you can copy, change, and work your way down the page. And so when I refer to a syntax file, what I'm referring to is sort of a list of all the commands that you've done in a given session. That way you've documented what you've done and how you've done it. And once you've done something once, you can then refer to that if you need to do it for a different homework or a different data set, and there's an efficiency there from not having to recreate the wheel. I promise, Girl Scouts honor. I used to be a Girl Scout, sell cookies and all of that. I promise not to make you do anything that I haven't given you exactly the right code to do. The only things that you'll have to change are the specifics of what I'm asking. Eagle Scout, okay. Yeah, I quit Girl Scouts in like the 5th grade or something. I remember I used to sell cookies. I was like the one going door to door, like with my dad in his truck outside, making sure I didn't get abducted. And I worked so hard to sell cookies so I could go to horse camp. That was my dream, was to go to horse camp. And I finally made it one year. And you know what? Horses stink. I was really disappointed that it was like, oh, you mean poop camp? That's what this is about. It's just horses are big and scary and smelly. And, my heart wasn't in the cookies after that anymore. But I can still swear on Scout's honor. No more poop camp, though, for me. I promise, circling back here, I promise not to make you do anything I haven't given you an example for. So this is an example of how to tell Sas to spit out frequencies for a categorical predictor. So proc freq. Colors in Sas mean something. Everything that is a dedicated Sas keyword that it recognizes is in blue. Anything that's in black is something that you may have to change. Proc stands for procedure. So everything you do in Sas where you're asking for information to come back to you is some kind of procedure. Can you guess what freq stands for? Yeah, I can't lip read, I'm sorry.
Frequency?
Yeah, frequencies. Proc frequencies. One thing about Sas that's different than Stata is that Sas allows you to have multiple data sets open at a time. Therefore, whenever you ask it to do something, you have to tell it what data set you want to use to do that thing, that procedure. So data equals is referring to a particular data set. And in Sas data names, the first part of it is where it is. It is a library, as it's called. It's a place that Sas understands where that folder location is. Work is a temporary directory. Everything we're going to do this semester is taking a data set and reading into the temporary directory. So by the way, this is the kind of thing that I'm going to go over in my videos, if you watch those, with Sas open in front of me, running things so that you can see what happens as the code gets executed. Example 1 is the name of the data set that goes with this because it's lecture 1. The word table is, okay, which columns do you want me to do something with? And the name of the column is called marital. So this is a good example of a good variable name. It's short. You don't have to abbreviate it further, but it's fairly descriptive as to what the column contains. And then run is always necessary to complement the proc. So think of it like a sandwich. It's like proc something is the start, and then run is the end. For those of you who've seen SPSS syntax, that's equivalent to the command execute, or exe in SPSS. The way I think of it is run is like asking someone to say please. Like my 5-year-old, Mommy, can I have some milk? Oh, I can't hear you. I didn't hear that. Mommy, can I have some milk? He says louder. No, I still didn't hear you. Please, can I have some milk? Yes, now I heard you. So it's like, can I have some frequencies? Please? And then it will go. If you don't say please, it will hang. You'll just see like this message that says proc freq ... like it's literally waiting for you to say please. Is there a keyboard shortcut for run? There is a keyboard shortcut to execute the code. So once you type it, nothing happens until you say read it and do something. You can highlight the code, and the keyboard shortcut in Windows is F3. There is also a little running man icon in the program that you can click over to. I'm not sure what it is in Mac because I'm not a Mac person, but I'm sure there is a keyboard shortcut for it. But you have to type the word run to close the proc command, like it's set. So that means that if I give you homework 1, then you would potentially have to change the name of the data set to whatever your homework 1 data is called, and the name of the column that you're asking for information from. And then this box is what pops up in another window. So output is my word for the information you've requested. And this box highlights the 3 different attributes that each column is going to have. The name of the column is marital. The label of the column is this that's across the top. So this is a label that I typed in that says marital means 5 category marital status. Then these words are the value codes. So this column is nothing but a series of numbers, 1, 2, 3, 4, or 5. But I have told it, hey, 1 means this, 2 means this, 3 means this, and the results of those instructions are the labels that you see here across the rows. So the labels help you keep things straight. The first column after that is frequency, which is a count, the number of people in the sample who answered, yes, I have a 1, or no, I'm a 2. And then it knows how many total cases you have. So this cumulative frequency right here, the 1974, that's your total number of cases in the data set. Homework question. And by the way, I had a student tell me that inside the YouTube video, you can search for phrases that I say, and that she's actually searched for homework question, cough, and it like pointed to that section of the video. So just as an FYI. So out of 1,974 people, 900 said that they were married, which is a percent of about 46. So we get the cumulative frequencies and cumulative percents, which don't make a lot of sense for a nominal variable like this because it's not really an order. It might make sense if this were an ordinal variable in which the categories sort of went from least to most. The same thing in Stata, by the way. The words right here, just those 2 words. So Stata code is a lot less typing. In Stata, up until the very last version, so most examples that you'll come across, Stata only has 1 data set open at a time. So that cuts down on you having to tell it which data set you're going to do something to because there's only 1 choice. The command tabulate is analogous to frequencies. There is no like proc precursor. In Stata code, the commands are case sensitive. Everything is case sensitive, meaning it matters if you type marital with a capital M or a lowercase m. It has to match whatever the column is named, and all of the Stata commands have to be in lowercase, which bothers me. So that's why whenever I refer to Stata, I put it all in capital letters just to be ornery, because I like to have commands capitalized and variable names and options like title case or lowercase to make my code easier to read, and they won't let me do that. So that's just me, trying to stick it to the man. So tabulate means make me a table for this column called marital, and this is the table that spits out. So it looks similar to what gets spit out by Sas, although it has cumulative percentages and not cumulative frequencies, but it does give you the total down here of the number of people that it read information for in your data set. Okay, how are we doing? Okay, questions? Any of that you want to hear more about or differently? Yes, please.
So for Stata, we don't need to like have a run command or something. You just click enter in.
Nope, you just highlight that, and it's Control D in Stata is the shortcut. There's also a run button that you would click.
I always write these shortcuts down because I always forget to enter the run command, and nothing happens, and I just look at the code. So that's fine.
Yeah, it's very like the people who made Stata make it so you don't have to type very much. The plus of that is that the code is very simple, but you have to know exactly where things go. Like Sas is more explicit, like it's like, here's where the data set goes, here's where the list of variables go. Stata just sort of assumes that you know what goes where. Okay, now caveat. I'm pointing at my screen like you know what I'm looking at here. Here's where the big pink mouse is. That's what I'm looking at here. In your homework, if I ask you for the proportion of cases in a given category, you have to convert these percentages to proportions. So that means you would not enter 45.59, you would enter 0.4559. I have answered that question at least 10 times in the last 2 years. So I'm hoping that if I make a big enough point at the front here that won't trip anybody up. The reason for that is because if you were to do analyses involving that proportion, like to compare it to a different number or something, it's entered as a proportion. So everything that in terms of what it would do with it behind the scenes is in proportion. So it just makes sense to keep it that way. Here's a picture. So if you are giving a talk, for instance, it's job talk season. I went to quite a few job talks last semester for P&Q, and I think TNL and RCE are having searches right now. If you give a job talk, you do not put tables of numbers up up this, right? This is not friendly, this is not helpful. What you do is you make a picture. So if I wanted to summarize the distribution of a categorical variable, I would make a plot like this, which is known as either a frequency plot or a bar chart, bar graph, because each distinct category gets its own place along this axis, which is known as the x-axis, and either the amount or percent will be shown on the y-axis here, the up and down axis. And so this conveys much more readily that most of the sample is married, followed by never married, and then there's very few people in the other three categories. And to make this picture in Sas, it is this addition to the table line. So in Sas, slashes separate options for what you want out of the column. So marital is the name of the column, slash plots then is, okay, what do you want me to do with this besides just spit out the table? And I'm saying, please spit out a bar chart where the scaling of the y-axis is in percentages. To do the same thing in Stata, it's this line histogram down here where a comma separates options instead of a slash. So this set of options here is necessary to create a picture that looks just like this. In your homework, I am not ever going to ask you to make me a picture, but I want you to know how to make a picture because you will need that information for the rest of your life. If you're making a poster, giving a talk, figures for manuscripts, and that kind of thing. Okay, questions, comments? All right, then what about quantitative variables? In this case, that type of plot is not going to be helpful. So one of the variables in this data set that I'm playing with, and by the way, this is the General Social Survey data set from, I think, 2012 or something. It went with the textbook with Stata code that I recommended, and so I stole it to make some examples out of. They have a variable for income in thousands of dollars, personal income. And if I make the same sort of frequency table for every unique value, this is what I get. So clearly, they're already doing some sort of binning or rounding of the categories, but knowing how many people are in each particular amount of thousands of dollars is not very useful. So to summarize a variable that ranges more continuously, continue-ish, where the numbers actually mean something, we would want to make a different kind of plot. This is the frequency plot that this table implies, not helpful. Instead, we want to do what's known as a histogram. So let me show you what it's going to look like, and then we'll come back to the code. This. So a histogram is a frequency plot where you have rounded things into bins. So you have like a range of, say, $0 up to $2,500 is the first bin, and then $2,500 up to $7,500 is the second bin. So you lump values together into convenient intervals. That way you can better describe the overall distribution of the data. So this thing is a histogram, not a bar chart. Excel does not do these, by the way. You have to make the bins yourself, whereas the software will do that for you. So to do a plot like that, we have a different procedure in SAS, which is known as proc univariate. This will spit out basically any piece of information about a variable that you can think of. It's a very, very general procedure that can give you an overwhelming amount of information, actually. But the structure of the command is very similar to what we had for procfreq. First step, after which proc it is, okay, what data set do you want me to go into? Note the semicolons at the end of everything. Semicolon is a big deal in SAS. All the lines, all the commands have to end in semicolons. Instead of table, it wants to know what variable. So that's what var stands for here. Many of these SAS commands have an option for var, meaning which columns do you want me to do something to. And the name of the column is called income. There's a line then histogram, make me that picture for income. And then the slash gives me options. And then midpoints is how I tell it how to make the bins. So if you don't tell it how to lump the values together to make a picture, it will decide on its own what it thinks is appropriate. I wanted to control that so that I could show you better. So this is in thousands of dollars. So the range of income from this sample, I'm saying plot from $0 to $70,000 in increments of $5,000. That's what that means. And the same thing happens in Stata with the same command histogram, and then telling it we want widths of 5 starting at 0. And so that creates this picture right here. So if we look at this picture relative to the previous one, we get a very different sense of where the income distribution is, because this frequency chart doesn't really understand the differences between these values on the x-axis, whereas this one does. So this is an example of a quantitative variable that I would say is bounded, because you can't make no money. Less than no money. Actually, you can. There's a comedian that did a bit about that, about their bank account being overdrawn, and the phone people, the bank people calling him up and telling him that he was overdrawn, and he's like, I don't have no money. I have less than no money. So it is possible to have negative money, but not in a survey where they ask you, how much money do you make a year? So the lowest you can make is no money. And in this case, I think the minimum for the sample was something like, yeah, $200 a year or something like that. Okay, questions, thoughts? Doing okay? Yeah, okay. So quantitative variables then. They have salient features that we want to describe, 3 of them, and I'm willing to bet you've heard of this before. So central tendency is one of them. What is sort of the middle value? And I remember teaching this course in person before the pandemic hit, and I asked my class, what's a mean? And one of my students is like, the same thing it was when we learned it in grade school? Correct. That is what the mean is. You all know what a mean is. It's the sum divided by the number you summed. There are different kinds of means, though, which is probably not something you would have learned in grade school, at least not in my grade school. This is the arithmetic mean as opposed to a geometric mean or a harmonic mean or other kinds of means that are out there. And even though all 3 of these measures of central tendency start with M, mean is the one that gets the letter M in results sections. So if you see the letter M equals in a text or as the header of a table, it means mean. And everyone on Earth has just decided that that's an acceptable abbreviation. There's also median and mode. And these tend to be used less frequently. Median is the middle value. If you lined up all of the values in order, it would be the one that is physically in the middle list. Mode is the most frequent. Dispersion is the second thing that we would want to pay attention to. So beyond just where's the middle at, how spread out are the people in my sample? So for instance, when people ask how many kids I have, I tend to say something like, I have 1.5 kids. And then they get the eyebrow raise, and I explain, I have a stepdaughter who comes to visit us during the summertime and over holidays and stuff like that. So sometimes out of the year I have 2 children here, and sometimes out of the year I have one. Thus, I have 1.5 children. Now, if I told you that the average age of my children was 10, that sort of paints a picture in your head as sort of what my house looks like, right? What kind of toys might be lying around, when bedtime is, that kind of stuff. But then if I clarified and I said, no, I have a 6-year-old and a 14-year-old, the average age is 10. That's a different kind of household than a household that has, say, an 11-year-old and a 9-year-old, which is my brother's household. So just knowing the middle doesn't necessarily tell you the full picture. You want to know sort of what's the spread around the middle. And the term for that is dispersion as a concept. We indicate dispersion in one of 3 ways, 2 of which are basically telling you the same thing: standard deviation, variance, and interquartile range. So standard deviation is abbreviated SD. It is how far on average any one case is from the sample's mean. So within a sample of people, standard deviation tells us the average offness of any one person from the mean. If you take that standard deviation offness and square it, that's variance. So you only need to report one or the other because they're telling you the same thing. The way that we are going to, I mean the program, is going to calculate these things is by starting with variance and then converting to standard deviation, which is why we have both of them. Standard deviation gets used more descriptively. It will turn into variance when we get into models. We'll be talking about variance that is explained versus variance that is unexplained. And people don't use standard deviation in that context for whatever reason. The other way to talk about dispersion is something called interquartile range, which is if you change the data into percentiles. It's the distance between the 25th percentile and the 75th percentile. And the reason that we have these different ways of thinking about dispersion has to do with whether or not the grouping of the data is symmetric around the middle or whether it's sort of lopsided. And that symmetric versus asymmetric distinction is what's known as skewness. And so that's whether or not there's a pileup of peoples on one side of the mean versus the other, or whether it's sort of equal. This is something that we would report descriptively and think about in planning our analyses, but it's not something that you would usually do anything with beyond that. It's not a feature that gets recreated when people do models, for instance. So, do these words sound familiar? Standard deviation, variance, skewness, that kind of stuff? Yes, okay. Then here's some notation to go along with it. So notation is language. When people describe something, they're going to use specific terminology, letters, numbers, and whatnot to describe it. And so I want you to start getting used to seeing this and unpacking what it means. So starting with just a mean. You all know what a mean is. You all know how to calculate a mean. Here is the notation that goes along with those ideas. So this term right here, y, that is a letter that's going to represent the variable we're talking about. Sub I, so the subscript of I, that indicates that y is a variable that varies across individuals. If I didn't have an I on there, it would be a constant. So when we get into models, you'll see that some of the components of the model are constants and some of them are variables, and you can tell which is which based on the subscripts. So this is y sub I, the outcome for person I, individual I. Big N, capital N in italics, is your sample size. Excuse me. The number of people in one sample. So y sub big N is an abbreviation for whoever's the highest number person in your sample, the last person. So that way, if you look down here at the numerator of this, y for the first person plus y for the second person plus yada, 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 that's what dot, dot, dot means. For those of you who've seen Seinfeld, yada, 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 y sub n. So that's whoever's last. And then divide by big N. This idea right here can be described more compactly with our friend capital sigma, which means sum over. Sum over what and stop at what is the question. So starting at the first person, I equals 1, up to all the people, capital N, we're going to sum y and then divide by n. And then the result of that added up, divide by n, is our friend y bar. That's what the thing over the top means, which is notation that conveys the sample mean specifically. So the mean for a particular sample, you can say y bar equals, or you could say capital M, that's italics, equals as well. You'll see, depending on who's writing the article, if it's like a stats article, you'll see y bar. If it's an article that's for social sciences more generally, you'll see an M. Okay, how we doing? Okay so far? All right. Variance then. So that's how we get the mean. We need to know the mean in order to get the variance. So variance then is, start in the inside of the parentheses here, y for each person, y sub I, minus the sample mean. So how far off are you from the sample mean? That's what the quantity is in the parentheses. And then we got to square it. So we have to square it because some people are going to be above the mean and some people are going to be below the mean by definition, right? The mean is in the middle. And so to prevent the positive deviations from canceling out the negative deviations, we got to square it. So we take how far off you are from the mean, we square it, we sum it up over all the people, and then we divide by n minus 1. And that gives us our sample variance, and that is denoted S squared. N minus 1, by the way, instead of n, is because we had to know what the mean is, the y bar, in order to do this. So it's like we have to penalize ourselves for needing information first in order to make this calculation. Later in the semester, that idea of how many things we had to know to do this is going to be called degrees of freedom. Denominator degrees of freedom in particular. You can think of denominator degrees of freedom as a bank account. And it goes up to n degrees of freedom because you got n people. And every time you calculate something, you take one away. Did the mean? Take one away. Going to do the variance? I would take one away. And so as we add things to the model to describe how the model would predict a given variable, each time we add something, we take one away. So denominator degrees of freedom is what that's eventually going to be. So then standard deviation is just the square root of this thing. And note that that square root just rolled right off the top of my tongue. That takes years of practice. I don't know if you know this or not, but those of us who are from the Midwest, can I get a hell yeah? Midwest represent? Oh, okay. So we're in the majority, I think, in this class. The correct pronunciation is square root if you are from the Midwest. That is correct.
Where are you from?
I am from Omaha-ish.
No, so you're from the north?
Oh, is that the north?
Yeah, if you just pronounced it root
Yeah,
instead
root.
of root, no. False statement.
False statement. Oh, I'm getting checked. There may be regional dialects, but I just know that, like my husband from California is horrified when I say root. Like, and so are people from the East Coast that I've taught before. But sort of the middle, maybe it's north south. There's a variation, but root. Like if you go up on the roof and drink your root beer, you take the square root. Like that all sounds perfectly fine to me, and not to others. Exactly. But I've trained myself to say root just so that I don't get that look. So the square root is how we get standard deviation. So if you're wondering, why do we have to have standard deviation and variance if one is telling us the other? It's because we got to start with variance and then we unsquare it to get the average deviation. The average deviation could be positive or it could be negative. That's the story behind that. So visualizing then what the impact of the standard deviation is. Both of these variables were created as fake data with a mean of 100 in each case. But the picture on the left depicts a variable that was created with a standard deviation of 10, so a variance of 10 squared or 100, whereas the picture on the right has a standard deviation of 15. So bigger standard deviation, bigger variance means more spread out. Relative to the mean is a less likely value for any one person to the extent that there's a lot of dispersion around it. So that's the story there. Both of these distributions, though, are symmetric. There's a relatively equal number of cases on either side of the mean. How to get that sort of information from Sas and Stata then? Instead of proc freq, it's proc means. There's about 18 different procs that will give you means, by the way. This is just one of them. Asking it what data set I want to use. Instead of table, here's the var for what column I want to pull information from. And then what information I want is up here with the keywords. So N for sample size, mean, STDDEV, it's abbreviation for standard deviation, minimum and maximum, and also note var here. In a case of terrible human factors, var here is not the same thing as var over here. Var in the top line means I'd like the variance as one of the numbers you give me, please. And var over here is which variable, which column. So they're two different things. And this NDEC equals 3, by the way, is 3 digits after the decimal, is the level of precision that I want the output generated to. I put that on there just so that the results don't look too crazy. And when all is said and done, after you say please with the run, you get a table that looks like this. So 734 people in this data set. The mean of income, which is the variable that we're working with, is 17.3. So on average, people are reporting they make $17,303 a year. Any one person, though, standard deviation of 13.8-ish, the average distance of any one person's salary from the mean of 17 is 13. So that's a pretty wide range, off on average by 13. 13 squared is 190. And then the lowest value is 0.245, and the highest value is $68,600 that's reported in this data set. In Stata, it's summarize instead of tabulate. So for quantitative variables, it's summarize and proc means. For categorical variables, it is tabulate and proc freq. And it tells you the same information. Note that it doesn't have a variance column. If you want to get that column, there's an option, it's comma detail, that will spit that out for you. So this is the kind of thing that I'm going to be asking you to do on your first homework that's not due for like another month or so. The point of the homework is to get you to wade into a software package like Sas or Stata for the first time. The things I'm going to be asking you to do, though, are not that bad. Ask it to spit out the mean, ask it to spit out the variance, and that kind of stuff. So this is the kind of information that you would typically put in a method section to describe the variables that go with your analysis and your research questions. All right, that's actually a good transition point. So just seeing the chat window, rough as an alternative pronunciation. Can I get a demonstration of that one?
I was on the rough with my friends.
You were on the rough with your friends. I think that's a little different than my roof.
I do it really like extremely.
Yeah, like rough, as in like rough housing or something. Yeah, which is probably another phrase that may be just a Midwestern thing. When I was younger, my mom used to say, "You better start being have." And it wasn't until I was about 25 that I realized how, like, what? You better start being Have. No one else? I grew up in a special kind of place, right? We go to poop camp up on the roof. I better start being Have because we're about out of time. All right, questions or comments on any of this stuff thus far?
Do you wash or wash?
Oh, good question. I do not wash. Absolutely not. There is no R in that word. And yeah, I'm also, I do say soda because people used to laugh at me for saying pop when I lived in other places. So yeah, I've like gotten that one. Poop camp. It was Camp Nishnabatna. That rings a bell. Team pop, yeah, or soda pop. Split the difference. That works too. All right. Fun with vocabulary. Anything else before we call it a day? All right, then thanks for coming back. Thanks for sticking with me. If you get a chance and you're curious, you can start diving into the videos to get acquainted with Sas or Stata. Otherwise, just hang tight and I'll see you next week. All right, peace out. Have a good weekend.